NASA found it. A thin, clean signal from space, not noise, not a flare, but a whisper from Alpha Centauri that vanished the second the dish turned away. In simple words, NASA may have caught a signal from an alien machine. Also, filmmakers said 5 more signals were hiding in the same data. Tight, strange, maybe even connected. Let us take a closer listen, because one of those new signals might not be a mistake. A strange signal, a simple start. In 2019, a big white dish stood quiet in the red dirt of Australia. It pointed toward the stars and listened, not for voices or thunder, but for tiny sounds from far away. This dish was called the Parkes Radio Telescope, and it had one job: listen to space. That year, scientists aimed it at Proxima Centauri, the star next door to Earth, just over 24 trillion miles away. Not far, if you think in space miles. What he heard would surely shake the search for extraterrestrial life to its very foundations. They were not looking for aliens. They were just checking the star. It was small, red, and gave off bright flashes called flares. They wanted to understand what it was doing. But then, something happened that no one expected. As they sorted through the data, a college intern named Shane saw something strange. It was a signal, but not just any signal. It was narrow, like a straight whistle in the wind. The signal showed up at 982.002 megahertz. That is not a place nature usually makes noise, and it was not something our satellites or cell towers use either. The scientists checked again. The signal was still there. It stayed for hours, but then, when they turned the dish away, it disappeared. Just like that. It did not follow the telescope. It stayed with the star. That was the weird part. Most signals from Earth stick with the equipment. This one did not. They gave it a name. Breakthrough Listen Candidate 1. BLC1 for short. It was a maybe, a strong maybe. The kind that makes your skin prickle, the kind that gets people dreaming. For over 60 years, people have been listening to the sky, hoping for something that sounds not natural, something that sounds like a machine, something that might mean we are not alone. There have been signals before, big ones, loud ones, but always, in the end, they turned out to be stars, or dead stars spinning fast, or even microwaves in a break room. But this one felt different. It followed rules. It was narrow, which meant it did not come from a star. It drifted a little, which meant it might be coming from something moving through space. It showed up only when the telescope pointed at Proxima. Then it was gone. That was enough to make the team pause, enough to make them test and test again. They looked for anything on Earth that could trick them. Airplanes, satellites, radios, no matches. The signal stayed strange, and that kept it alive. Some people started to wonder, what if it really was a message? Maybe not to us, but from someone, or something. A machine on another planet, a transmitter in a far-off place, something not built by us, just working quietly out in the dark. But science is slow and patient. They did not rush. They turned their tools back to Proxima. They looked again and again. But the signal never came back. It stayed silent. Just one flash in the dark. That made it harder to believe. Still, the buzz around it would not go away. It had lasted for hours. It was narrow and clean, and it passed every early test. That meant something. That meant it could not just be tossed aside. But more teams started to dig in. They opened the data wider, looked closer, and what they found started to change the story. They saw other signals, small ones, signals with shapes and patterns like BLC1. They were not from Proxima, they were from Earth. They looked like echoes from machines, like something made by clock tools deep inside other equipment, machines we use every day. Tools that hum and tick and send out their own signals, sometimes without us even noticing. That was bad news for BLC-1. It meant it might not be from space at all. It might be a copy, a side sound. Something made here, bouncing off something else and landing right in the telescope's ear. A new paper said the signal was drifting, not because it was flying through space, but because it was made by two signals on Earth crossing over, like two radio stations mixing by accident. A trick of timing, a ghost made from machines. The team who found BLC-1 was careful. They did not say for sure that it was aliens. They never did. But they did say it was the most exciting signal they had ever seen. And when the other tests came in, they accepted the result. It was likely just interference, a mistake from Earth, not a voice from the stars. That should have been the end. Just another almost. Another maybe that turned into a no. But not everyone gave up. A filmmaker named Simon heard about it and said he had talked to someone close to the telescope team. He said 5 more signals had been found, not just random ones that also looked clean, tight, like machine talk, not like anything from nature. These signals were found in the same data, not from a new place, but from the same files they had already checked. He believed they were signs, maybe not full messages, but pieces, whispers. Simon said some of the teams were still working, quietly, not ready to share yet, but close. He said they were almost ready to tell the world, and what they would say might change everything. The signal faded, but not everyone was ready to move on. Some believed the real story was only just beginning. The buzz returns, or does it? The signal had too many odd pieces, the drift in frequency, the tight band of radio waves, the sudden stop when the telescope moved. These were not things you see every day, not things you can easily explain. Most noise from Earth follows us. This one did not. It came, it stayed, then it vanished. Simon Holland was not a scientist, he was a filmmaker, but he paid attention to space news. He followed the Breakthrough Listen project and listened to the people behind it. Then he said he had news of his own. Simon said he got a tip, a quiet one, a message not meant for the public. He said someone in the field had told him something new, that BLC-1 might not be alone. That deep in the files from 2019, there were 5 more signals, not from another time, from the same data set. Signals no one noticed at first. Strange, narrow signals that looked just as weird and just as sharp. He said these were not just static, not just broken noise. They had a shape, a pattern, something that might point to machines, and maybe not our machines, machines not from Earth. He called them candidates. They had not been proven, not tested like BLC-1, but they were there, sitting in the data, waiting for someone to look close. That was the new piece, and it shook the story. Simon made a video. He said the teams were not done, that even after the papers said BLC-1 was a no, other groups kept working, digging deeper, trying to be sure. And maybe soon they would be ready to say something big, something world-changing. Most people didn't know what to think. The signal had been explained. The science was solid. It was most likely a copy from something near Earth, a fake. But Simon said no. He said the game was not over. That made the story come back to life. People started asking again, what if BLC-1 was real? What if the papers were wrong? What if something was trying to reach out and we missed it? Back at the Breakthrough Listen team, the scientists were careful. They had not seen the 5 new signals Simon talked about, at least not yet. But they did agree on one thing. The search should continue, not just because of BLC-1, but because the sky is big, and strange things do happen. They kept the Parkes dish aimed at stars. They ran more checks. They changed the tools they used. They added stronger filters to block out human-made noise. They knew the odds were low, but they kept listening. Every signal was now tested harder than before. The team had learned from BLC-1. They had learned that even the best-looking signal can be a trick, that machines on Earth can copy the voices we hope to hear from space, that even a small wire out of place can make a signal look like a visitor. But they also knew that sometimes the first sign is quiet, the first message is small, the first buzz is easy to miss. So they checked everything, not just Proxima Centauri. They turned to Alpha Centauri too, a star group that includes Proxima and 2 other stars. Alpha Centauri A and B are bigger, brighter, and sit just a little farther from us. Some scientists believe they might have planets, maybe even ones like Earth. If a signal came from Proxima, it could have also come from somewhere else in that system. The Parkes dish covers a wide sky. The beam it uses is not a laser. It is more like a flashlight. It hears sound in a circle, not a line. So BLC-1 could have come from somewhere else in that circle, maybe not Proxima at all. That kept the questions alive. Was it from a planet? Was it from a satellite we missed? Or was it something older, colder, drifting through the black with a signal still running? One thing was sure, the galaxy is loud. Our own Earth is full of signals. GPS, radio, Wi-Fi, satellites, weather machines, military systems, and more. They all hum and beep and send waves. Sorting space from Earth is like listening for a single whistle in a room full of fans and engines. The scientists said it again and again. It is not easy to tell what is alien and what is just us. The only way to know is to hear it again, to catch it twice, to catch it steady. That never happened with BLC-1, but the team didn't stop. They built better models. They studied how Earth's machines drift and mix. They mapped out every signal they could find. They cleaned the air, so to speak, so the next time they heard a buzz, they would know what it was. Other groups joined too. New telescopes, new teams, some in the US, some in Europe, some in South America. They all wanted to take part in the next big signal, because even if BLC-1 was a false start, it showed how close we were, how ready we are. BLC-1 may not have been a message, but it was a lesson, a reminder that strange things hide in the data, that space is wide and full of surprises, and that the next signal could come any time. People still dream about that day, the day we catch the real one, the day the buzz does not stop, the day we see it repeat over and over. Not noise, not Earth, not a trick, but a pattern, a call, a sign that someone is out there, watching, waiting, maybe even trying to say hello. Even with the silence, the search kept growing, because something about that first signal still pulled at the edge of belief. A quiet sky, a louder future. As the months passed, the buzz faded from headlines. BLC-1 became just another name in the long list of maybe signals. Most scientists had moved on, not because they stopped believing, but because belief is not enough. Science needs repeat. It needs data. It needs answers that hold up again and again. Still, Proxima Centauri stayed on the watch list. It is too close to ignore, just over 4 light-years away. That is a short walk on the space map, and it has planets, at least 2. One of them, Proxima Centauri b, is Earth-sized. It sits in the habitable zone. Not perfect, but possible, except the star flares. And it flares hard. Studies from the ALMA telescope show that Proxima Centauri blasts its planets with radiation storms. Enough to strip away atmospheres. Enough to make habitability a big question mark. Even so, astronomers kept watching. Not every day, but often. Telescopes took turns. Some searched for light. Others listened for whispers. Meerkat in South Africa joined the Breakthrough Listen project. 64 dishes, sharper ears, tighter focus. They aimed at nearby stars, including the Alpha Centauri system, listening for anything odd, anything that might be more than static. Back in the US, the Green Bank telescope stayed in the game, one of the largest steerable dishes in the world. It can stare without blinking. Software teams trained algorithms to sift faster, to catch the rare ones. Not the signals that shout, but the ones that whisper. Software became the new hero. Code now hunts what eyes cannot. Billions of signals, most of them junk. Satellites, planes, cell towers. But some stand out. Thin lines, narrow bands, signals that drift just right. These get flagged, tagged for human hands. People dig in, compare, break apart. Most vanish. Some linger, some raise eyebrows. But none have stuck like BLC-1. None have sparked the same fire. And yet, every signal teaches how to sort faster, how to spot false alarms, how to write better filters. Every wrong signal is one step closer to the right one. SETI is slow work, like fishing blind in a sea of echoes. You cast, you wait, you reel in noise and nonsense, but maybe one day something bites. And when it does, it will change everything. Some think the first real signal will be simple, a pulse, a ping, a wave that repeats, proof of a machine, proof of intent, just a whisper from far away. Others think it might be bigger, a song, a code, a message packed in data, a cosmic greeting we will spend years trying to unlock. But for now, the goal is modest. Hear it twice. Hear it from the same spot more than once. That is why Proxima Centauri stays in the crosshairs. If BLC-1 was not real, fine, but it proved how close we are, how sharp our ears have become, and it lit a fire. In 2025, Alpha Centauri remains a prime target, not just for listening, but for going. Breakthrough Starshot wants to send gram-sized probes riding on light sails, 20% the speed of light. That means arrival in 20 to 30 years. That is not science fiction. That is funded, real, with names like Yuri Milner and Stephen Hawking behind it. And there is more. The Sunbeam project wants to launch bigger probes, about 1,000 kilograms, using electron beams. They would go half as fast, 10% light speed, but they could carry more. Arrive in 40 years, still within reach. Meanwhile, space eyes are getting sharper. The extremely large telescope in Chile is under construction. Once it is online, it might be able to read the atmospheres of far-off worlds, look for biosignatures, hints of life, within a decade. And in 2026, the Tolleman mission plans to launch a space telescope aimed right at Alpha Centauri. A team-up between NASA and the University of Sydney. Its goal, find more planets, more chances. Some scientists even think Alpha Centauri might be sending us pieces of itself, interstellar objects. Tiny travelers drifting from their system to ours. 1 million of them may already be hiding in the Oort cloud. That number could grow over the next 28,000 years. All of this adds up to one thing. Alpha Centauri is loud, not in sound, but in possibility. New missions are forming. NASA is building better tools. Private companies are stepping in. Satellites are being designed to listen from orbit where Earth's static cannot reach. Even deep space probes might one day carry ears, listening as they fly past stars. The moon may host radio telescopes soon. No air, no noise, just the cold quiet. Perfect for picking up the faintest signals Earth can't hear. And if we do hear something, a real signal, one that cannot be explained away, that day will be remembered, not just in labs, but in living rooms. Because hearing from another world is not just about science, it is about us. It says we are not alone, that somewhere across the dark, someone else built a machine, someone else aimed it at the sky, and someone else waited. What if the signal comes and we ignore it? Smash that like button, Drop your wildest theories in the comments and subscribe for more deep dives into the unknown.